All right. So Roger, you can work directly with Kevin on that.
Thank you.
So welcome back. Thanks for coming back. Today, we're actually going to get into applying some of the concepts we learned yesterday. And we'll start to be able to use real data and find some patterns. So the first thing that we're going to do is go ahead and open back up that event engine and follow the process. You're going to go back to the console and hit open AWS console. And we're going back to where we were in SageMaker. Right. Then notebook instances and Jupyter. So a couple of clicks to get here. We're going to be working in the notebook called PyPy2, which is the introduction to.
So 1 second. So hey, Kyle, can we walk them through pulling the data folder really quickly?
No, actually, they can just use it like this.
Ah, okay, gotcha. Okay.
Okay, so Brian, you need help with SageMaker? Okay. So we went through Event Engine, and then you're at the homepage for AWS, the console here. You can type in SageMaker. There are lots of options here. We're looking for the one that says notebook instances. And then open Jupyter. Okay. Then we'll go into the PyPy course and number 2.
Kyle. Kyle, is it possible to download the PyPy2 into my computer and then just open it through Anaconda?
Yes, it is. So all of the material is available on GitHub. So if you go to this link, you can click the little green icon here. It says clone. And you can download it as a zip file, and you'll have all the materials.
Okay, but that way I can just like, because yesterday I was like conflicting with other people that were changing it at the same time. Thank you.
Thank you.
I was having a little bit of feedback, so hopefully this is a little cleaner. All right. So Pandas is the library within Python that we're going to use for the rest of the time. It is the library that I use most often because it allows me to manipulate data. I can bring in data from an Excel type format, either as an Excel file or as a CSV, comma separated value. Bring it into memory, into Python, and then do my analysis. It comes with a lot of really useful features. For example, auto sum everything in one column, or you can find the mean, median, mode, max, min of a column very easily. So to get started, in our notebook, we're going to come here and just start by importing pandas. As we talked about yesterday, there's an echo in my video still. Is that any better? Nope. Okay, is that better? Great. So you can do lots of different kinds of things with pandas or with Python. Python can make websites, it can make videos, and it can also do data analysis. So when we start anytime in a Python environment, we have to tell Python what type of work we're going to be doing. And we do that by importing different libraries. These libraries are made by other people, and they allow us to not have to spend time like recreating things. That's a really common thing that we'll do every time when working with Python is we'll do an import. And then we're going to tell it what we want to import. So we're going to import pandas. And by convention, we shorten the name from pandas to PD. Any tutorial you see on the internet about pandas will follow the same pattern. We're also going to import a thing called matplotlib. This is our basic plotting tool. And it's based on MATLAB, the structure of MATLAB. This last little thing with the %sign is something that we have to use just in Jupyter notebooks so that the results show up in the cells. So like talked about yesterday, the nice thing about Jupyter notebooks is you can have your code and your visualizations and your comments all together. This is what we need to do to make sure that they actually show up together. Below it, we're going to bring in our data. And it says something else here, but the data file didn't come through correctly. So you'll need to change that to this website, right? So if you'll just change what it says here, so it should say PD, so pandas.readcsv, and then within little quotation marks, this. That website is this data. And what's great is that we don't have to download it. We can just use it directly as it is. Pandas can open it directly from that website. So when we execute this, it's going to bring it in. And when this turns into a number, then we're ready to go. We have this new object called sales that is the file that holds all of this data. So if we run this cell below it, we can see what the top bit of the data looks like. So head is going to mean the top part. So it's, if you imagine like a spreadsheet from Excel, these are the top 10 lines. We can also make this tail to see the bottom 10 lines. That's one way to get a sense of the data. So that method, we have lots of other methods that we can do. So here are some examples that help us get a sense of the data that we're working with. So let's try sales.describe. And for each of the columns, it's giving us the count, the mean, standard deviation, and the quartile ranges here. A quick way to get the summary of the data. We can also do something like the mean, and so that's going to give us the mean of each of the columns. If we only care about units, then we can use brackets to distinguish that we're only talking about units. So if you look at the one below, so sales is the overall data frame. That's all of the data. Within brackets, we're going to separate out just one column that we're interested in using. So we put the name of the column there. Let's just, if you do that, it's going to print out the whole list. Since there are 20,000 observations, Actually, it's going to cut it so we don't have to see all 20,000 things. We can apply these same methods that you saw before just on this column. You keep getting an error.
Yeah, I put in the raw.github user content link on in the sales.pd read underscore CVS or CSV, and right after I clicked right after I ran that, I got a name error. It says name PD is not defined.
Did you run the cell above it that says import pandas as PD?
I don't think so. Try that. Oh, okay, that worked. Thank you.
Cool. Yeah, so if you don't tell it what PD means, then it doesn't know how to bring it in. So I'll just put this whole thing in the chat. Right, so you can copy that as it is and put it in a cell after you've imported pandas as PD, and that should bring your data in for you.
Thank you.
So now we can subset the data. We can take sales, and if we just want to see the average for sales, now we're just applying the method that we had here above, but just to that one column. You can look at the max value, the min. So really easily we can start to get those values that give you a sense of the data, right? So these are just descriptive statistics, standard things. Same kind of thing that you would do in Excel if you highlight a column and at the bottom right corner, it'll tell you the statistics, things like count, right? So that's a way to get a sense of what you've got. Now we're going to talk about some of the concepts of why this is valuable and some of the things that you may not be able to do very well in Excel. So if we just look at the data here, we've got this order day, which is a date. And we might want to keep that information along with units, right? So let's make a kind of a new data frame that's going to have a condensed version of what we want. So we want to include the order day for our date, our GL and our operations. So what we're doing is we're creating a list of things to keep. And then we are going to use that list here within sales to just look at the top items for those things. So now we've got a smaller amount of information we're getting back, a little easier to read. So you can look up at the top, we had, let's say 1, 2, 3, 4, 5, 6, 7 columns. If we're not going to use all of them, then just bringing it down like this makes it much easier to see. All right. We might also want to get a sense of the types of data that we have here. So let's look at what are the unique values within our product family. So there are 4 distinct values, right? This is a nice categorical variable. It can take on 4 values. That's sort of useful, right? But that next cell below it is actually going to help us and tell us how many, the frequency of these. So now we're starting to be able to do something that's kind of similar to what you can do with a pivot table, but really quickly get a sense of how the data is breaking out into these categories, right? And so it says product family here, but we could, this could be another type of column. So if you swap out product family here for ops, so ops is a numerical column, so we can just take the sum of that and very easily get the result. All right. Now we want to make a new column that we're going to add to this. Right? And to do that, we already know that sales is a data frame. So it's already like a spreadsheet. If we're going to add a new column, then we can just say there's a new column and it's called country. For this example, all of our countries are going to be the United States. So we're going to put US there. Now when we build this, we have a new column we've added here for the country. Right. We can also do work within the columns, so we can add them, subtract them. We can divide operations by units, and we can make this its own category or column too, just by saying sales ops. Right, so operations by unit. So I'm going to save this, and it's going to go row by row, just like you see here. It's going to give me a result row by row. So if I do the head of this, I'm going to get a unique value for each row. Right, a really easy and fast way to start to do this. The way that data frames work is they are built on the same idea as lists that we talked about yesterday. So it is a collection of lists. Any of the things that we could do to a list, we can now do to the data frame. So we can sort it. We can find a specific number within that list. So like find the 10th item. We can also use conditions. So we'll find the items where product family is equal to consumables. So let's do that as an example. Let's say we want sales, where the sales product family is the same as consumables. And then we can say units, let's take the average of that. So this is the average of units when the product family is equal to consumables. And we can easily change this to one of our other ones. Our options are here. So let's change this to media, because it's capitalized. Right, so now I've got a big group of data and I want to segment out different parts of it. So in economics, one of the common things we want to know is how are the groups within a data set different? Is there a difference between men and women in this data set? Is there a difference between people who are older or younger, people who took this class and who did not take this class? And so this is a way that we can start to pull different parts out and segment our data so that we're looking at the things that we're interested in. Right. Now, what I used here is a double equal sign, because a single equal sign is the same as an assignment. So if you use a single equal sign, that means give the value to this thing. A double equal sign is equal to a test of truth. And so it's going to work only when this is true. Only when the product family is the same as media are we going to do this thing. Right. So it's checking if this is true or not. All right.
What does the units part is, Kyle?
That's just in our data set here.
Okay.
And I don't actually, this is not real data, so I don't remember what units means. I think it's like number of objects sold.
Okay. So you're telling them on my data set sales, look at the product family column, those that are equal to media, and count the units. Get the. Oh, okay. I see what you're saying. Okay.
Yeah.
All right.
So for all of the ones that are media, what is the average of units if you are in the group media?
Got it.
Right.
As I was reading it, I'm like, I answered my own question.
Yeah.
Thanks.
And so I could also assign this to a variable that I might want to use later. So we'll call this the Dr. G variable. And now if I need something later, I can say like print Dr. G, and it has that value. So this first part, anytime you start dealing with a data set, you do normal exploratory data analysis. So we just want to get a sense of what's the data look like. So it's a little hard when you're just looking at the numbers. An easier way to get a sense or feel for the data is to do a visualization, and we're going to come to that in a second. Another common thing that you might want to do is to segment things out based on the kind of rows. So do a filter, and you can see, we can look at things based on if they're from the product family, this group from Amazon Pantry. We can also do it based on our order day. So for, how many orders do we have on a given day? The and gives us two conditions. So we want to see what are the sales when the order day is July 1st and the group is apparel. So there's only one observation that meets that. So we're here. If we change our and to a pipe, that's an or. So we're going to get the values of it will be true if it's this date or if it's apparel. So you'll notice we have things that are apparel that are different date. And we have things that are not apparel, but they are the correct date. So that's another way that we can segment out our data. So the ampersand means and, so it gives us two conditions, and the pipe is an or. So we talked yesterday a little bit about conditions and loops. You're actually doing those things, but with Pandas, you don't have to type it out the same way. It's much easier to do. You can just write this little syntax here, and we can get that same result. All right, let's start talking about some visualizations. One of the things that is a little tricky at first when you're working with Pandas is you can create subsets of data that you might say with different names, but they're not actually unique files. So if you're working in Excel, you may take all of the data out of, you might do a filter in Excel and then copy that data and put it into a new spreadsheet. Then if you change something on the original spreadsheet, it doesn't affect the second spreadsheet. That's not true in Pandas. If you make that split and you make changes, then you can affect both, because the second one is just, the .loc is location. It's telling it to look row by row. So in order to avoid that issue, we're going to use .copy, which says, I don't want to just reference back to the original data set. I want a new copy so that they're completely distinct. And now whatever I do to my toys data set doesn't affect sales, or what I do in my sales data set doesn't affect toys. It's just a way to separate that out. Another thing that is really nice is that we can create an index. By default, your index is a number that begins at 0 and just counts up. That's not terribly helpful for we humans. So what we're going to do here is we're going to change that index to be equal to the date. So now we've got this as a time series, and we can really easily plot time series. If you notice here, normally in time series, you need to or any plot, you need to give an X and a Y. So it knows what to do. Because our index is time, it already knows that the X is equal to time. And so what we're looking at is just operations based on time. You'll notice a little as well that this is a matplotlib plot. This is the base level plot, and they're not particularly pretty. Later on, we'll talk about some ways to make much more pretty charts and charts that have some interactivity. Right, so we can change here again from ops to something like units, and we'll get the plot of units. You can also do things like change from plot to hist, and now we have a histogram. So for data that's going to have some kind of normal distribution, this is a really nice way to get a sense of how your data is spread. If you remember from your Bandit courses, you can look at see if the data is skewed. You can look at the peakiness, the kurtosis of your data, all with just changing out how we're doing this. So I've got hist. I can also change it to box. Maybe it's box plot, or it's not. I'll go back to hist. There we go. All right, so already we've been able to go in and bring our data set into memory and start to do analysis on it, start to break it apart in different ways and hone in on what we want. One of the great things about this is that we have left a trail of everything we've done. Someone can come back and look at all of the different steps, and they can see any transformations that we've done to the data and how we're ending up with these results. Right? That's something that you can't do in Excel, and it makes it really easy to understand like why these transformations happened. Also really useful because if you you make some really great analysis in the Saturday night when you're at home doing data analysis, and then you want to go back a few days later to repeat it, that can be hard to remember all the different steps you've done. But with the notebook format, it's all very clear and explicit on what you've done. You can also type in comments to yourself like we have here to remind you of why you're doing different things. Okay, so let's go through and make a couple of additional plots. Now we've got 3 plots we can show all kind of separated out. And you can start to look on the time series if there's some kind of connection. Clearly there's some event that happened here, excuse me, that's anomalous compared to the rest of the data time. Maybe there's a big sale that caused a big spike and then a return to more of a normal level. Right. And we've already talked about histograms. We can change our bin size. So if you've ever fought with Excel to create bins, this is a much easier way of binning your data and being able to change it. Okay. If you just delete the part that says data slash, this should work. What we're going to do is save this to as a new file. So if you go back here, you can see you have a new file. That is our sales output. This thing is really cool. You can use this to clipboard. Oh, paperclip. Right. But you can do that, and then you can put it directly into Excel. So you can copy and paste it that way. Okay. See, this is another syntax for how you can do different columns. So rather than putting things in brackets, what was the print input before the plot? I don't know that question. But what we normally do is sales and then would use brackets to do GL. So these two things are the same. I prefer this style because it's much clearer on what we're doing. So this I find very confusing, and but you may see it, I guess, sometimes. But this is the better way and the preferred way to segment your data with the data frame. Okay, awesome. All right, so that's kind of our introduction to Pandas. Now let's go into some slightly more advanced concepts. If we go to Notebook 3, we're going to start to do some more advanced ideas. So as before, we're going to start by bringing in pandas and matplotlib. What we're doing here is just setting some of the parameters on how big we want things to print out for pandas. Like, so when we look at a data frame, how much of it we see. And those are just kind of preferences. This cell is not going to work properly because the data folder didn't come through properly. So you can change path here to the link that I put in the chat.
Could you post that link one more time?
Yep.
Thank you.
All right, so now I have a variable called path, and it has this name in it. So the nice thing about doing this is I can refer to it generically. So I can now I can say pd.read CSV path, and it's going to know to go to and get that data. If we decide to change it and use a different data set, then we could change it here, and this would still work because the path is just referencing wherever we're going to be pulling our data from. So that's our first part. So pd.read CSV. If you have an Excel file, then all you need to do is to change this to read Excel, and it will read in an Excel file. So something that's .xlsx. If you've got data that is separated in other ways other than a comma, so you could have things that are, you can use a space to delimit things. You can use tab. You can do sep equals, and then put in whatever's the delimiter. So it could, for this example, it's a comma, but it could be a tab or even just a space. Sometimes I'll use a pipe. So there are different ways of delimiting the data. We'll tell it to comma. And then our question here is, how do we just see the top bit of the data? So we've got this data frame, and we just want to see the top, and that's with the head method. Right? By default, head's going to give you the top 5, but within the parentheses, you can put another number, and it will give you the top 20 or the top 50 or whatever you want to see. Right? Okay. All right. So we've got our data that we can bring in. We can use our print statements and start to examine the data a little bit. So we've got the index is going to go from 0 all the way to 20,000. We can see again the range of it. It's going to go from 0 to 20,000, and it goes in increments of 1. There's a question before about the lock. What's nice is that we can start to pull out just sections of it. So especially if you're working with time series, you may want to have a period that I want to see all the data up until June 1st, and then I want to save the data after June 1st for something else. So lock is a way that we can start to separate data out based just on the index. So these are index numbers. It's the same as here. Right. We talked yesterday about our data types. Pandas automatically infers the data type, which is really handy. Sometimes, though, it will give you errors, especially if you're working with like an Excel spreadsheet, and it may think that certain columns are strings or characters when they're supposed to be like a date. So if you look at the data types, you can see what it thinks each one is. So this is an integer, these are floats. And it doesn't know that our order day is a date, right? So if we wanted to look at things based on date, like show me all the things that happen on Tuesdays, that would be nice to be able to do, but it needs to know it's a date. So we can easily change that. We've got 2 columns that are date columns. We can have a little for loop, and we're going to say for column that's in this, right? This is referencing this list. You could also say for I in here, and then change that to I, because this one needs to change too. So now I've changed these to date time. So the word column here doesn't matter as long as it's the same. The important part is that you have this list that you're going to go through. So we've got 2 columns we want to change, right? Go through, use the Pandas to date time function. So it's going to take data and convert it from like a string directly into date time. This is a really powerful tool because it can take data that exists in lots of different kinds of formats and convert it to a date time. And then once things are in date time, it can understand things like show me all the values that happen on a Tuesday, or take this and add 72 hours to it. And you can do manipulations that way to get a sense. One of the things that often happens in time series is that your sales data for the weekends is different than your sales data during the week. So maybe you want to be able to pull that apart or use that as a feature. Make a new column that says this is a weekend, so it gets a value of 1, and then the weekdays are a value of 0, and then you can include that in your regression to see if there's a different effect that's associated with a weekend. By changing things to the date time format, you can do that. Right. So here we've taken this and we can start to see the days of the week. Now we've just got a lot of more options on how we organize the data. We've also, as we did before, moved this order day into our index. And now that it's the index, it allows it to make those charts really easily. So we can easily say df units dot plot. And since it already knows it's time series, it's just going to easily plot for us. We talked before about segmenting things out. So when working with time series, maybe you only care about a certain period of time. So this is a period of 5 days. You can start to say, just show me the results for these 5 days. Another really common thing that we might want to do with this data is to aggregate it. So if we care about our quarterly sales, we're going to resample means to change the frequency of the data. So Q is going to change it to quarterly, and it knows when the quarters end. So first quarter is going to go from January 1st to March 31st. It knows all that for you. So give us a resample based on quarters, take units and give me the sum. We can also do M, which is month. So resample and give me the month summaries. So you can see the monthly values and they're the quarterly end of the quarter values. So all of a sudden we've been able to do, yes, you can format the date. If you want it to be like an ISO style, you can do that. In general, once it's here, unless there's a specific reason to change it, it's easier to leave it that way. But you can, if you wanted to change the format, you can.
Is it possible, for example, if I wanted to say,
so
should be just weekends?
very quickly, we've been able to summarize this data and get some meaningful information. We could change our Q to year, and we can get the value for the year. So without having to kind of create extra cells or click around or do pivot tables, we're now able to dig directly into the data and start to do aggregations. This is sum. We could also change this to mean, although I'm not sure how meaningful that is. We could change it to max, so it's the maximum value within the year. Right. That resample is a really powerful way we can manipulate the time series. I'm going to leave these as things that you all can go through. And we're going to drop down to here on this group by and aggregations. So group by and aggregations is basically the idea of pivot tables. If you care about things based on certain characteristics, so in economics, we want to see things like what is the value of the product family. So group it by the product family and then give me the sum of units and ops. And we can easily do that. So now we've created this pivot table that has our products and the sum of each of the for the units and ops. If we don't want the summation, just like a pivot table, you can change it to count and you can get a frequency table. We can change this to standard deviation and get the standard deviations of the columns, or something like min. Right. So now, again, we're able to slice and dice our data in different ways using the group by function. So the first argument for the group by is how do you want things to be organized? So we wanted them to be organized by the product. And then in brackets here, this is a list, right? That's a list of the columns that we want. We could also create something like, so we can create a list here that's our columns of interest. That would be units and ops. And it functions the same way. If you are a SQL fan, this is what we just did. All right, so now we can start to change some of these ideas together. This next one's going to give us the same results we had earlier for summations. But now what if we want to group things and resample and get just the top values? So we've got things organized by the GL, the kind of the date. So that's our index. So we actually have two indices here, units and ops. And it's rolled up to a quarterly level. If we just change this to a monthly level, we can get the same results for the month. It's not showing the others because of this head is only going to show you the top 12 things. Right? Really easy way to start moving things around. Now that we can do that, we can start to also get maybe more information about a column. So we want to see units and we want to see the average of the units and the sum. And for the ops, we want to see the low and the high. Right? So we can do the same thing with the group by. Here of my categories. Units is these two things. So I've got my sum column and my average column. And then for ops, I've got my min and my max. All right. I can save this as an object that I might want to use later. So basically, this is a new data frame that I have access to call later. Yeah. All right. We're going to go down to pivot table. So pivot table is one of the things that I use all the time in analysis. So if I've got different groups and I want to see how do they compare, I'm going to do a pivot table or a cross tab and easily compare them, then that's what we're doing here. And then this new table I have, this new object I have called pivot table, has all the same features that I can use in a normal pivot table. So I can take this, since these are columns, those things we did before with the aggregation features, it can now do, right, to these. So that is organized by the product family and the average of that column. All right. So these last two concepts are a little bit more harder to get your mind wrapped around. But if you can take data and you can pivot it, you can actually also unpivot it. And that's something that Excel can't do. That allows you to take something and kind of reformat it. And the last idea is called melt. When we're dealing with data, we often get it in a format that's not user-friendly or not friendly for the computer. So it doesn't follow the rules of what we would call tidy data, where every row is an observation and every column is a variable. That can make it really difficult to do visualizations and tools like Tableau or Power BI. So whenever I use those tools, the first thing I'm going to do is actually come into Python and melt the data, which is going to take the data from a wide format into a long format that is much easier than to use in something like Tableau. So we can take the data from here to be really long. And since it's really easy to sort and categorize things that way, and we can still apply those same features in order to pull out things like what is the max for this group or that group. It gives us that ability to really find the different components that we care about. All right, we're kind of at the end of our time here. We went through a lot of different concepts, but I hope it's clear they all kind of build on each other. There are little things for you to try as well to go through. But are there questions now that people have?
I think Mien had a question. Yeah.
All right. So tomorrow we're going to have a real data set. It's a data set from Airbnb values in Toronto. So it's the listings for Airbnb up until about mid-March. It's going to have lots of columns about the different attributes of the properties that are available, how many people can stay there, whether or not they accept pets. And we're going to use that data. We'll do pivot tables and some cross tabulations, and we'll start to do some regressions. So we'll apply some of those higher level concepts onto it. And you'll see that doing a regression on a data frame is just as easy as doing something like finding the mean. It's very straightforward, and it's incredibly fast, especially compared to Excel. So the data set that we're using today is 20,000 observations. The one we'll use tomorrow is about 400,000. And if you bring that into Excel and try and run a regression on it, it will take forever. But with Python, it's going to be very quick to do the regression, even on that giant data size.
Kyle, where can we find the recording of this lesson?
Did I scare everybody off?
Hey, Kyle, can you hear me? There was a question from a few people asking where people can find the recording for these videos.
So we're going to post them on the Econ website. I've got to talk to Fidel about when we're going to do that. Whenever.
I mean, yeah. I mean, we just let me know when you're ready, and we'll put it on our website, and we put a password protected so that But yeah, and we share it with the people in the cloud.
Yeah.
Is there any way we can do that today so we can kind of go over what we've done previously to get ready for tomorrow's class?
Yeah, let me put them in an S3 bucket, and then I can send everybody a link that's going to work for that. Yeah.
Thank you.
Yeah, that way you can kind of go through it again and get a sense of how we did it. The documentation for Pandas is very good. So if you come to the Pandas website, there's really nice documentation. I've also included some books here And I think there are even more listed. Oh, so like
I
this,
use that. I'm sorry. I use that Python for data analysis to kind of get my head into this, and I thought it was really, really useful for those who want to kind of get a copy of that. That's a really
oh yeah,
good
this book is great. Another one I really like is by Jake Vanderpass. So the data science handbook, all of his, I think the whole book's available, but all of his code is available here in GitHub. So you can actually go in, he's got all of his notebooks, and you can see how he describes doing all these things, like how do you sort, how do you do pivot tables. And this code, you can just copy it, right? Like cell by cell if you want, or you can download it and have it. So this is using the famous Titanic data set where you try and predict who's going to survive the Titanic. This is a really common problem for learning how this works. So that's another good resource from Jake. One last thought on here. It can be a little overwhelming if you just search on the internet for things, and sometimes you get some bad answers. So there's a site called medium.com that's my go-to place, because they have really nice tutorials that are step-by-step. So if you can, there are lots of things like, here's how you subset data in Pandas using lock and iLock. These articles are going to be really easy. So they go step by step. So that's a really good resource. This website, medium.com. There's a limit on how many articles you can read for free, but it's like $60 a year. So I paid the $60, and I think it's worth it. All right, so I'm looking forward to tomorrow, where we're going to use this on a real data set and start to do some real analysis. And then Thursday, we'll get into doing some work with stocks and time series.
Kyle, I have
Right?
one more question for you.
Yes.
When we're working on the exercises in the different sections, is there any way that we can check our work to make sure we're doing it correctly?
There is a folder here called answer keys, which doesn't have the answers in it. All right, so no, apparently not. That's something that I will work on as well.
Thank you.
Yeah.
I have a question.
Yes.
I was working on the exercises yesterday, and I realized that it matters how much you indent, I guess, when you are doing the functions and
okay.
The for loops, I guess. So I was confused on that. If you could help.
Yeah. So one of the ways that Python gets away from using curly brackets or using like tags, like you might see in a website, is by using space as an important feature. So tabs are an important indicator of things. So if you have a for loop, then it needs to be indented. So that's 4 spaces or 1 indent for all the things that are going to be part of that loop. And then I can also do a loop within a loop, and this will be indented relative to that loop. Okay. So let's see with this, we're going to change this. I'm going to create my Kyle list. My Kevin list. So there are 5 things here. My 3 and Kevin's 3, and so we should get 1, 2, 3, 4. We got 6 outputs because it's combinatorics. So yeah. two of Kevin's for every one of mine. But yeah, that space is important. And if we want to have a condition, so we could say if I equal 1, we can, that again is another indentation. So point being, indentation is important. There are only a few other languages that use indentation as being important, and you use space this way. So YAML is a markdown language, and Python are probably the two that uses the most heavily. But other computer languages like C++, JavaScript, Java do not use space this way. So
Okay. Sounds
if you
good.
come from MATLAB, then it is a pretty big difference that the spacing is important. It's not just an aesthetic thing. Now, hitting enter does not matter. And you can have spaces, so it is fine to have something like 8 space. So this is going to be, if I can do, those spaces don't matter. So it still works. But if I brought this down, that's not going to work because it's not the same line. All right. Does that help? Anita?
Yes.
Thank you, Kyle.
All righty. Thanks, everybody. Have a great day, and we will see you tomorrow.
All right, bye-bye.
Thank you.
Hello, Dr. Carl.
Yes.
I thought you were going to stay behind for some of us.
Yeah, I'll stay behind if you need to talk about something.
Yeah. So I'm staying.
Hello, Dr. Carl.
Hello.
Yeah, so I was trying to get to the environment you sent to me this morning.
Yes.
So I was having trouble since I was not able to join yesterday, so I was just having some challenge to the environment. You sent me the mail this morning.
Yes.
For the environment. So I used the code, the password. So but let me just let me go to the environment. Let me go there.
Okay. Do you want to share your screen then?
Okay, yeah. So let me share my screen.
I need to give you permission. Hold on.
Yeah, so I'll just share my screen now.
You don't have permission yet. Hold on.
Okay, yeah.
So, Dr. Ka, I have similar problem, so I think I'll be following you.
Okay.
So here is my screen. So I'm at this point now.
Uh-huh.
I don't know.
Hit notebook instances where your cursor just was. Yep, right there.
Okay.
And then go over to see where it says Open Jupyter down to the right,
okay.
Right there.
Okay. Yeah.
Okay, so now you're here. Open the file that says PyPhi course. Yep.
Okay.
And this is all the material we're going through. So we went through 2 and 3 today.
2 and 3 today. Okay.
Yeah.
Okay. That's fine. Okay. So, okay. So, also yesterday when I was going through the material, I observed that in page, so in page on page 4 of the material list. So we're trying to run the code my list 3 column 8, and the output we are not really able to follow Like we're not really able to understand why that would be the output there.
All right, so one thing is that Python begins with the number 0.
Okay, 0. Okay, 0.
Yeah.
Okay, because when we counted it, we have
Yeah, when you count it, it
0,
looks
1,
different.
2.
So so the number 3 is in index spot 0.
Yeah. So we have 0, 1, 2, 3. 0, 1, 2, 3. So, but when we did that, 0, 1, 2, 3.
And the 8
So
is
start at
so
6, and then the 8. What does the 8 do? 3.
that is the end. So it is you're a math
Yeah.
person, right?
Yeah.
So it is up to but not including 8. So in math you would do a parenthesis.
Yeah. Oh, yeah.
Right.
So
Up to but not including.
6, 7. Yeah, I get that. I get it.
Hey,
Thank you
Kay,
so much.
I want to ask you a kind of a question. I just want to find out. So, with you, let's assume with you in the job market, now with all these codes, do you kind of create a folder where you keep your codes in so that when you want to refer to, you just go there and look at what to use? Or how do you do it? Do you have to bump your head with all this stuff?
Yes, you must memorize all of this stuff. So I showed you the GitHub. I'm going to show my screen again. I need to become the presenter. Oh, rats. All right. So if you go to www.github, GITHUB, I would really like to be able to show my screen. Reclaim. Great. Okay. So there are lots of ways of doing this. This is the way I like to do it. There is this website called GitHub. It is a place that you can also come and get lots of different kinds of code that people just post for themselves and for the world. So if you want to type in Python economics, you'll find all of these different places. You can look at this person's code for quantitative economics.
Oh, okay.
It's like it's all here. I have my own area within here. I don't want to create an account. I want to sign in. So this is my area. I've got different projects that I work on. So this is the class for today that we're working on. This is a folder I have of things about geoscience, because I work in oil and gas. This is the class that I taught this year. Maybe not that one, but one of these is the class I taught this year, this one. So this is the class I taught at SAM. So I've got my slides here, and I've got my exams, all my material. This is private to me, so no one else can see this.
Okay.
But I can host it here for free in the same way you could use something like Google Drive or the SAM Drive. It is a little confusing at first to learn how you're supposed to put your information in to this website and how you get it out. It requires using this protocol called Git, G-I-T. But once you know how to use it, it's really awesome because things go in and out, and it actually keeps track of all the changes that you make. So we can look actually at the changes. Kevin and I are working on this project together, and we can see the changes that he's made, changes I've made, right, on each one. So you can, it's version control. You can go back and we can see how these things change over time, which is really, really fantastic. If you're interested in learning how to do Git, the Programming Historian is my favorite website for this.
Okay.
This is a website that is designed to teach history majors how to code. So it's really easy.
Okay.
if you're a business major, you can totally do this. Get find the right one.
Hey.
That's it. So follow this article, and it will teach you how to do it. How you take your stuff and you put it there. It is free, and it's what people do in this space. So if you're talking about getting a job, it is very common to create something like this and then share it with a potential employer. So I've got my code there, and I can then share it with somebody I'm trying to get a job with. I did a competition about 2 years ago, data science competition, and I put my code here, my submission code, in that competition, and then I can send them a link. I don't remember which one it is. Send them a link and they can access it that way.
Good.
You can put your code here. You can write in any language you want. So you can write in Python or R. That notebook was R, or any JavaScript, Julia, whatever you want, Scala. So that makes it really easy. And there are a lot of examples on how you can make these really pretty, how you can make websites for free for your stuff, and use that as well to get a job. So that would be my recommendation.
Okay, thank you.
Yeah, so go to GitHub, and then you can follow this tutorial on Programming Historian. I'm gonna try and put this here in the chat.
Hello, Dr. Kyle.
Yes.
Yeah, yesterday when we were trying to practice what we did, so it got to a point, the interface, it wasn't running. Each time we ran the code, it won't run. So I guess we were timed out or something. So I was like, is there any way we can always go back to that interface and rerun whatever thing you have taught us earlier?
Yeah, it shouldn't time out on you. One thing that can happen, excuse me, with these examples is if you make changes, and you try and rerun it, it doesn't always work because you've already done the transformation it's expecting you to do. So if you're supposed to take something from an integer and make it a string, and you do that, and then you try and redo that cell, it won't work because it's already happened. So the best way to deal with that is to go up to the top here where it says kernel, and just hit restart and clear output. And that gives you a fresh start to go back at the top, and it kind of drops everything out of the memory. So you can start at the top and go back through.
So this page is always there for us to go to anytime we want to go.
Yeah, so this environment that we've given you with all the code inside of it is good up until tomorrow evening, and then it's going to go away. But you can come and you can hit new, and you can make a new one, and this will save in this environment through tomorrow. What Fidel was kind of talking about is like what happens after this class, and you have a couple of options. You can download the free version of Anaconda. Right, so you download it, put it on your computer, and you can run Python code this way. Or you can go to AWS, and you can sign up for a free account with us. As a student, you'll have a free account, and you can use the same environment. You can use SageMaker like this, right? It'll be free for you.
Oh, so you don't, I mean, with AWS, you don't need to download anything on your computer. You
Correct.
can just sign up and then use it straight from your.
Yeah. So what's great about it is it's all in the cloud, which means you can have a much better computer running this than your laptop. For example, we probably have turned this off for you, but up here there's a thing called examples. And here's a notebook that you can actually open up and run. And this notebook is going to use a GPU, which is a graphics processing unit, to classify images, which is very expensive, but you can use it to do your modeling. And then you basically rent it, and then it goes away. That's really cool. So that's not something that is available in your free version right now, but that's one of the reasons that it's nice to do it online, because that's better than my local computer. But there are lots of free ways to get Python to run on your computer. Another common one is called PyCharm. Right. This is also, it's free to get PyCharm. It just depends on how you want to write your code.
I do have the PyCharm on my laptop. I don't know if one can still get it online too.
There's not an online version of PyCharm.
All right.
So the ones that are online are primarily through the big cloud companies. So we offer it. Microsoft has one in Azure. It's called Azure Notebooks. And Google has one called Google Colab. So you can, I work for Amazon, right? So it's better. But you can go to Google Colab. Let's see. This is a project that I did in Google Colab with Twitter data. So you see it's the same idea, it's the same notebook. And what this code does is it goes and it gets tweets for people, and then parses the tweets and does sentiment analysis on the tweets, and then does some visualization of the tweets. Okay. So another way of getting and running Python online. And just like AWS, there's a free version that you can use. Is that making sense?
So Dr. Hill, I want to ask, how are we going to incorporate this class onto widows looking for a job out there? Is it like we're going to create something like a seminar and put this under the seminar, or I don't know where to classify our class into our resume so that at least somebody looks at them, know that you have an idea of what you're about to do?
Yeah. So I had talked a little bit to folks in the econ department about doing a certificate of completion or something. I think we still can do that. I don't actually know. So we'll try and think of something if you pass the final, right? But the other way is to demonstrate that you can do it by creating like one of those GitHub examples. So you have something you can show. And there are so many tutorials that will just like walk you through something step by step that make really beautiful things. So you can have something that's really impressive. And that way it's basically a portfolio that you would use. What we're gonna cover so far, like in 5 days, is great, but not enough for you to like be a data scientist doing Python yet. That takes a little bit more time. But yeah, no, this is a great start.
Okay.
So you tell me what would be useful for you on the job market. I don't actually know. That's one of the reasons we're offering this class, is trying to figure that out. I'm also talking to the econ department about offering a semester-long version of this, so people could get credit for it and have it on their resume,
okay,
in their transcript.
That'd be great. That'd be great.
Yeah. Part of the reason of doing the class the way we did was to find out if there's interest in a class like this. So 99 people signed up. I guess 98 because I counted one person twice. Nicholas, I counted you twice. But that's in order to set up a new class, you have to prove to the dean that there's interest. So that's a good proof point for that.
So in that case, do we have we those participating now? Do we have to play a role in doing that?
You don't have to do anything. No. You should take my class in spring 2021. It'll be awesome. We're going to do way more than we're doing in 5 days. Hopefully people still want to talk to me after this. Yeah. So Spider, David mentioned Spider, which is another IDE.
I think with I don't know whether you can create something like a certification class, so that wouldn't be like you have to be a full-time student or you have to be enrolled in SAM before you can take the class. I don't know whether that is also something you're looking up onto, so that those who are out there can also sign up to the class.
Yeah, so some of the other universities offer like boot camps. Rice does a boot camp that teaches the same kind of material. They charge $10,000 for it.
Ooh.
So you're getting the free version, which is, I know the people who teach the boot camp, so it's, our version is just as good, better than that. But yeah, maybe we'll figure out how to do that. I've also talked to some folks about other types of classes. For example, I'm thinking about doing one on R, which is another statistical language, in September for International Talk Like a Pirate Day, like a one-day workshop on R. So maybe we can put these together and make something nice out of it. I don't know. There are some websites like, let's see, Udacity, where you can do classes, and they have a class. They have mini classes. Let's see, let's search. So on their data science, and they've got visualization. Here's data science with R, we were just talking about. These classes tend to cost money. Here's data science with Python, which is kind of what we're doing. So it's talking about Pandas, which we did today. And then I was just talking about Git and GitHub. So that's here. There's a way of doing this that I think is free, but there's also a way to pay and get a certificate. So you can put that on your resume. I think it ranges like, I think it's like $300 a class. I don't know. Sorry, I don't remember that. There are a number of ways of doing this though.
Okay.
So lastly, I just want to ask on my side, the pandas that we did, is it that pandas is just a data, right?
Yeah, so Pandas was called a data frame
Okay,
you use for, you kind of as a wrapper around your data set.
Okay.
So each column is an array of numbers.
Okay.
They're vectors that you can then manipulate. And what Pandas allows us to do is to vectorize computation between things. So if you wanted to do a dot product between two columns, it can
Okay.
very quickly do that because they're already vectors.
Okay. Okay.
I don't say that to the rest of the class because they may not know what vectors are, but
Yeah. Yeah, I get it.
So that's why it's nice to use. You're not required to use them or to use Pandas. It's probably the most common thing to use because it does make things a lot easier. But you can also just work with things as arrays. And if you know matrix algebra, you can do that directly as well. There's a very good book called Data Science from Scratch that will go through how to do all those things. So if you wanted to write the code yourself for doing dot products or doing linear regression, that book talks about how you do that.
Okay.
And without using Pandas.
Okay.
But in the world of data science, so if we use Kaggle as our example, so people can post, this is a competition website. People post their notebooks. There's a section here for notebooks. Every one of these notebooks is going to begin with importing Pandas. If it's, I guess if it's Python. So that's import Pandas. It's the first thing that you do. Right. So this workflow, like that kind of top thing, I don't suppress the warnings, but bring in pandas, bring in matplotlib, bring in your data. That's what, when I was a data scientist, I did every day. That's the bread and butter. Once you've got your data in your data frame object, then you do what you want to do for your analysis. You can see these are much prettier plots than what I showed you. This is using a special library called Seaborn, that makes prettier plots than the base level matplotlib. But this is, yeah. So there's, I guess another way to think about this. If you go to this part in the environment we gave you, there's a thing here at the top called SageMaker examples. And there are like 100 or so examples here. It keeps going. There are just so many of them. And if you click on the preview, don't click use, but click preview, it will show you the notebook. And you can see how it works and how it does these things. So these are all written by people who do this for a living. So you can see like everybody's going to import pandas, everybody's going to import matplotlib, and NumPy is another library that pandas is built on NumPy. So you can then just kind of see how people do it. I think looking at these examples can be really helpful for understanding what your code's supposed to look like. The only danger here is that there are more advanced concepts that I didn't use this because I didn't want people to be confused. Like this section right here turns your data into a tensor. But all right, you're a mathematician.
Yeah.
You take your data frame, you turn it into a tensor, and then your computations are substantially faster.
Okay.
Right, but there's some challenges with how you build the tensor. For example, it has to be a float 32, not a float 36, not a float 64. But by changing it into this format, record IO protobuf, then you can take advantage of some distributed computing. You can do a lot of other things with it.
Okay.
So this is more like a machine learning stuff, right?
Yeah, so this is a machine learning. This example is predicting breast cancer.
Oh, okay.
And it uses a thing we have called linear learner, but I think specifically it's going to use like logistic regression to do it. There's lots of different ways you could do this. In that set I showed you of all this list, there are a number that use deep learning. So if you wanted to see something that uses TensorFlow or PyTorch or MXNet, some of the higher level neural network type stuff, there's examples here of that. Yeah, so this here, DeepAR is a neural network for time series. We're not covering this in the class because it's frankly too complicated for what I wanted to do. But what this does is it takes a time series and related time series and uses that to make predictions, which makes it much more efficient than a standard approach like ARIMA.
Okay.
Thank you so much, Dr. Kai. Thank you so much.
I hope that those words made sense to everyone.
I know there's a lot going on now, but I mean, I think by the time we are done with the class, we'll be able to get a lot of stuff to start with. So
yeah, well, so these first 2 days are a lot of the foundation. Tomorrow we're going to go through a real data set, which I think is really important, and you'll kind of see the thought process of how. So it's something I did. So all my steps are kind of outlined and the way I was thinking about it. It's all together. And then on Thursday we can do time series. We'll talk about how you can bring in live data. So it's stock data. You can get stock data up to the minute to do analysis. So you can make predictive models to do
So you can just import a live data straight on your computer?
Yeah.
From online?
Like, don't put it into Excel ever.
Oh.
Yeah. So go get the live data, right? And what's great about that is once you've built the library, once you built your notebook, there's no data in the notebook. You just say, every time I run the notebook, go get the live data and bring it back. So it's always fresh.
Okay. So you're always going to use the link in getting your data, right?
Yeah. So for that one, yeah, it's a link basically.
Okay.
But the link is, the values that are at the end of the link are always changing.
Okay.
That makes sense.
Okay.
So if you imagine like a restaurant, and you're the customer at the restaurant and you want something from the kitchen, you tell the waiter what you want, the waiter goes and gets it and brings it back to you. Basically, it works that way, that you say, hey, I want the stock price for gold right now, the commodity trading price for gold. And then the waiter goes to the kitchen, gets that answer and brings it back to you.
Okay. That's cool.
Yeah, it's really cool. So, and that's what the folks that are doing algorithmic trading are doing, but at a much more advanced scale. That we're gonna get there. We'll start talking about the same concepts that they're using.
Hello, Dr. Kyle.
Yes.
Yeah, thank you so much for what you've been doing. But I just want to ask, how soon can you expedite action on the video, so that on our own, if we are running it and we rush, we run into each, we can refer to the video and just see how you do it, and then go back to it.
Yeah, so it takes normally 30 minutes after I turn this thing off, which I guess I should have done.
So we can have for yesterday and today, then we can practice this before tomorrow, so that we can be at press with whatever you're going to do tomorrow.
Yeah, let me do it and post it, and so you'll have something to work on.
Yeah, just send it to me, then we get the link from there.
Yeah.
All right. Thanks so much.
No problem.
Thank you, Dr.
Right.
1, 2.
Okay, thanks everybody. Take care.
Yeah, okay. Bye.